Continuing on with chapter 1.2, looking at some more problems. We've already been talking about solving a simpler problem. We've done that in a couple other examples where you look at a smaller problem to see if that generalizes to a bigger problem. I'm not going to write the solution. This one I want you to look up in the textbook. This problem here about how many coins it will take to determine using on a balance, right? And so the textbook has a long, exhaustive, like a real long explanation of that. But again, it's a way of solving a simpler problem. Let's continue on with that theme of solving a simpler problem and looking at the answer to this one here, which is find the sum of these here. And so to find that, you say, well, I know 1/2 equals 1/2, right? And so the next one out of that pattern, right? The next one is 1/2 plus 1/4, which equals 3/4. So that becomes the important number, the sum. And let's continue to another one, 1/2 plus 1/4, 2 squared plus 1/8. And we continue with that. Your answer is going to be 7/8. And so a pattern emerges if you wanted to go all the way to 2 to the power of 10, which again is a big number. We end up seeing a pattern, and I started documenting some of that already. What it turns out is that the bottom number is always 2 to the power of how many terms you have, right? There were 2 terms, so it's 4. There's 1 term is 2. 3, so that's 2 to the power of 8. The top one always seems to be 1 less than the bottom, and so that's the pattern that emerges when looking at a simpler problem. And so you can see it's 2 squared minus 1, 3 squared, I have that backwards, 2 squared, 2 cubed minus 1, there's your 7/8, to the 4 minus 1 over to the 4, 15/16. So it turns out that you end up with this generic problem formula here. When you start it with something simple, a simpler problem, you get this formula. And so this is the sum for the first 10. When you go from 1/2 all the way to 1 over to the power of 10, this is what you would end up with. So that's solving a simpler problem. And again, like I said, there's some 2 other problems, learn checks, that in class you would work on this in class and spend some time on that. And they're involved problems. I have some solution here. In this case, I would solve a simpler problem. Again, I'm not too worried at this point about the solution. I break this into smaller problems and count how many rectangles are in here, and then I notice a pattern on that one. And so as you can see, as it goes up, there's 3 rectangles in here, and they'll look like squares. There's 3 rectangles, 1, 2, and then 3, the big one. Here there are 9 rectangles in here. Remember, a square is a rectangle, so we count that as a rectangle. You can see how I'm counting by the dimensions of each of the rectangles. 1 by 1, there's 4 of them. A 2 by 2 and 1, and so those are my totals. And so as I see these going up, I see a pattern up by 6. This went up by 9. And if you build the next one, 6, 9, the next set of values of the 4, if you had, so there's 3 there, and if you had the 4, there would be 30 different rectangles, because this would be up by 12. It's going up by 3. And so we're looking at this problem here, 1, 2, 3, 4. So I barely got here to 4 of them. I need to get 2 more, 5 and 6. So it's going to go up by 15, right? So 15 plus 15 gives me 45 for the next set. And then it's going to go up 18. And so then the next one for all of these would be 63. You'd end up with 63. And then this last one here of how many chairs would you have at the tables. I recognize a pattern on this one here. Make it a simpler problem. There's 6, there's 10, and then this turns out to be 14 if you count them up. There's 1, 2, 3. So if you notice, there's 4 per hexagon. How many hexagons? 3. There's 4 per hexagon, and then plus the 2 on the end. And so you end up with an equation of 4n plus 2. How many hexagons? 2. 2 times 4 is 8, plus the 2 corners, and there's your 10. 1 hexagon, 4 times 1 is 4, and so forth, plus 2 is 6. And so to get this answer for 27, what we would do is you're going to do 4 times 27 plus 2. And so for 27 hexagon tables, you're going to end up with, what is this, 108 plus 2, 110 chairs, if you do that right there.